In this video, we're going to look at the derivatives of trigonometric functions, sine, cosine, and tangent, and so forth. And so by the end of this video, you'll be able to calculate derivatives of trigonometric functions. Let's look at the graph of the sine of x. And let's try to graph a possible derivative of that. We know how to graph derivatives. We know that when the function has a maximum or a minimum, the derivative is going to be 0 or does not exist, but most of the time is 0. So each of these maximums and minimums are going to be zeros of my, so I've got one here, got one here, I've got one here, here, and here. And so you can see I've plotted those little dash marks on the x-axis there. Those are all my zeros of my derivative. So now we're going to divide up our function based on this. And to help us draw our derivative and look at, of course, intervals of increasing and decreasing. We know that the sine curve is periodic. We know that, and that this curve repeats itself, so we would expect its derivative to also repeat itself in a probably similar fashion here. So if I'm looking at this first section, the graph is increasing, so my derivative is in the positive, but it's approaching 0. And then we look the graph between the first one here and the second one over here. It is decreasing. So it speeds up, it reaches its mass point, and then it goes back to 0. Okay? Now, let's look at a couple spots here. Let's look right here. This, because we know that this would be an inflection point. Right here would be an inflection point, right there at the origin is an inflection point, and that is going to be the maximum rate of change or the minimum rate of change, depending on whether the graph is increasing or decreasing. So if I'm going like this and drawing my tangent line, you can see that my terrible tangent line there, that slope looks to be about 1. It looks to be about 1. So without going back there, and then that would mean the slope at a lot of these points are 1. The slope in the middle here, in the middle on the down, on these downs, looks to be about -1 if we take the slope by using our rise over run. So let's start it at 1. It goes down, it hits 0. It hits -1 here, comes back to 0. Hits +1, comes back to 0. Goes back to -1 to 0 to +1 here at the y-axis, back down to 0 to -1 to 0 to 1 back to 0 to -1 back to 0, and it keeps going. And that curve looks very familiar. That curve is the cosine. So it looks to us that the derivative of the sine equals the cosine, which it is. We're not going to go through an algebraic proof of why that is, but it has been proven algebraically that the derivative of the sine is the cosine. Now you might guess then that the derivative of the cosine would then be the sine. Okay? Well, we can test that theory. We have a graph of the cosine right here, and so we're going to graph that, and then we're going to compare it to the graph we have above. We can see how this function does compare. Okay? So we know again our maxes and mins here become the zeros. As best we can here. Graph these. There's going to be somewhere over here. It's also going to be somewhere over here. But now we immediately run into a problem. Our graph is decreasing, which means my derivative is negative. Now we know that it's going to go from -1 to 1, but the first part is going to go like this, which already looks similar to the sine curve, but not the same, because this one is, the sine curve is above the x-axis, my derivative here is below. So if we keep drawing this derivative as best I can here, you can see how it's very similar to the sine curve, but in fact it looks like a reflection of the sine curve over the x-axis. And if that's the case, that would be the negative sine of x. And that's what it turns out the derivative of cosine is. It's negative sine of x. Again, we're not going to go through an algebraic proof, but know that that is the derivative. Okay, so the derivative of the sine is the cosine, and the derivative of the cosine is negative sine of x. Okay, so now that we know that, we could find the derivatives of all the other trig functions, because all the trig functions can be written in terms of sine and cosine. We're going to start with the tangent. The tangent, we know, is sine over cosine. And so now that we know derivatives of those, and we know the quotient rule, we can determine algebraically the derivative of the tangent. So the derivative of the tangent, okay, and all of this, these rules hold true when your angle's in radians. If your angle's not in radians, your derivative is a little bit different. Okay? Similar, but a little bit different. So the derivative, that would equal the derivative of the sine of x divided by the cosine of x, which would be the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared, which we know would lead to, this would be cosine of x times cosine of x, the derivative of the sine, minus sine of x times the derivative of the cosine is negative sine of x over cosine squared. We write a cosine squared like that, which would then be cosine squared of x from this, a negative sine of x times negative sine of x is positive sine squared of x over cosine squared of x. And our Pythagorean identity here, this right here, Pythagorean identity, we know from our trigonometry that sine squared plus cosine squared equals 1. So this is going to equal 1 over cosine squared of x. And also from our trigonometry identities, we know that 1 over cosine is equal to secant. So 1 over cosine squared is secant squared of x. So from that, we know that the derivative of the tangent is the secant squared. We've just given a proof of that. Okay, right there. The derivative of the tangent is the secant squared. Now, we can do something similar for cosecant, secant, and cotangent using the quotient rule again. Okay? And we're not going to do each one of those proofs, though. We're just going to give you all the derivatives of the trig functions, because you will not be asked to do the proofs on your test. So let's look at the derivative, the ones we know. Derivative of the sine is the cosine. Derivative of the cosine is the negative sine. And the derivative of the tangent we just discovered is secant squared. The derivative of the secant is the secant tangent. And again, we're not going to go through the proof of that, but the derivative of the cosecant is the negative cosecant cotangent. and the derivative of the cotangent is the negative cosecant squared. Alright, so you need to know those and have those memorized. You will not be asked to recreate the proofs, so just need to know the various derivatives. Let's do a couple examples here. Okay. Differentiate y equals x cubed cosine of x. Well, we see right away this is a product rule. We have two functions, we have two different x's, so it would be the first times the derivative of the second plus the second times the derivative of the first, which would be x cubed times the derivative of cosine plus the cosine times the derivative of x cubed. So that'd be x cubed, and the derivative of the cosine is the negative sine of x, and then the cosine and the derivative of x cubed is 3x squared. This again is unsimplified, but there's not a lot of simplifying we can do here. Can't really combine much and do much else with it. Okay. So essentially the only thing they would do to simplify it would be negative x cubed sine of x. They would move the negative out front, plus they would move the 3x squared cosine of x out front, and that would be our derivative in its most simplified form there. Really, I mean, you could factor out an x squared if you wanted to, and so that would be negative x squared, and then you would just have sine of x minus, or x sine of x, 3 cosine of x. They may do that. Okay.